Stat students, we are going to have a quick lesson-ish today to close out this week. We are going to be talking more about position. So the last video lesson that we had, we talked about percentiles and how that describes where you are in a distribution. So if I were to say, how did you do on your last test? How did you do compared to everyone else? You'd say, well, I was about the middle, I was the best, or I was the worst. No, we have a more precise way to do that. We have percentiles. So say I was the 70th percentile. So you did better than 70% of the class. Or in the lower area, you'd have like say I was in the 40th percentile. So that at this point should have meaning to you where a value falls in a distribution. So we're going to continue this idea with a very important topic, like extremely important that you know about this way to describe position. Okay, so we're going to be talking about what's called a standard score. Also known as, and what we're going to be calling them, Z-scores. So this is another way to describe where you are in a distribution. Okay, I've got a definition here that I want you to write. This is also measuring position, so Z-scores. A Z-score tells us how many standard deviations from the mean an observation falls. Okay, that's what it's for. And compared to percentiles, a lot of times this is more useful when making comparisons. Okay, percentiles do a good job as well with comparisons, but sometimes it is better to have this. So this is how many deviations away from the mean a particular value is. All right, so we have this formula here. You're going to be writing that down as well. I'll pause, make sure that you've got this. I'll put in a screenshot. Here is the formula. So we'll make sure that we copy that down. So it's Z is equal to X minus mean. X is the observation, that is maybe your height, which we're going to talk about in a second, minus the mean over the standard deviation. Okay, how this might be shown symbolically on say a formula sheet, X minus X bar over S of X, right? That's sort of how that looks. We need to write down something else. We're going to write down some bullet points for this. First off, this is also known as a standardized score. So if I want to standardize something, it means I'm going to subtract the mean and divide by the standard deviation. That is standardizing it. Okay, it's taking away the whole numbers and it's simplifying them, divided by the mean and the standard deviation. Here's another bullet point. This is important for the problem set. Has no unit of measure. Meaning, if I get a Z-score of like 1 or 2 or 3 or 4, whatever, that is, it's not like 2 feet or 1 inch. That's not how we do it. It's really measured in, if we had to say it had a unit measure, it's in standard deviations, how many deviations you are from the mean. So remember what standard deviation is. Standard deviation is the average distance from the mean. So you want to know how many of those average distances you are from the mean. So it can be kind of complicated if you think about it. Okay, so we're going to go ahead and do this. You want to find your Z-score. For height. You want to find your Z-score for height. So let's pull up, you can pull up your calculator. I want you all to do this with me. Open up your calculator, I'll give you a moment. Go to Data Collection 2020. That is this file here in your calculator. I'll pause the video, let you make sure you get that up. So go ahead, I'll pause it, get that up. Then you're going to go over to the heights here, okay? And this is the column. We looked at this the other day with percentiles. let's go ahead and go all the way up and highlight it, and let's copy it. Do you remember how to copy? You're going to hit Control and then C on the calculator, and you're able to rewind in this video. So if you need to rewind, do that. Control C. Let's add a new page. Control Doc adds a page. Make sure you do List and Spreadsheet, and then hit Control V, and it pastes those heights. And let's name it, just put H in there, okay? So for us to calculate our standard score, like everyone knows their height, and I'm going to pick 61. Okay, 61 is going to be my the one that I go with. So I'm going to say from this formula, x equals 61. You will put your height here. Whatever your height is in that data set, put that. Okay, so 61. Maybe you didn't make it in. Just go ahead and put yours anyway. Let's just pretend like it's in there. What else do I need to be able to calculate this? Well, I need x bar and I need s of x. That's the mean and the standard deviation. So we need to find that, x bar and s of x. How do we find that? Well, we're going to go over here, we do menu 411. We learned that last chapter. Go ahead and make sure you've got a lot of options here. H is what we named our list. Hit OK. So we got it 65 point, we're going to round that up to 69, 6569, and then the standard deviation, we're just going to say it's 5. We can't round that up. So round that to 5. So standard deviation 5, and then this one is 65.69. Let's go ahead and do the z-score. So we say z is equal to 61 minus 65.69 over 5. Let's go ahead and calculate that. On your calculator, you can pull that up, and we can make a fraction. Control divide makes a fraction, so 61 minus 65.69 over 5. And we get negative, z-score is equal to negative 0.938. Okay, so negative 0.938. So let's talk about, we're going to write down some more bullet points. What does negative and positive mean? So if we're looking at our distribution of heights, let me go ahead and let's graph this. So let's do height. I actually want to take a screenshot of this. We're going to do that. And I'm going to put this in my notes. So let's paste this up. Okay, let's drag that down over here. How far down can it go? Right there. Okay, so if we're looking at this, we know that the mean is at 65.69. So where is that? That's probably about here. So let me draw that. We're going to say, okay, that is x bar. So where is this point 61? Well, 61 is going to be one of these 2 points. What do you notice about that? Well, it's below the mean, okay? Now, some people, let's say we did like 78 or any of these values above this green line, you would get a positive value. So on our bullet point here, we're going to say negative, actually, I don't even need quotations. So we're going to say negative z-scores indicate a value is below the mean. Opposite to that, you have positive z-scores indicate a value is above the mean. A z-score of 0, what does that mean? And it's totally possible. What is a z-score of 0? Well, that means that it's exactly on that green line. Is that possible in this case? No, because we didn't have any heights that are exactly 65.69. So that won't happen in our example, but it could happen. A z-score of 0 means or I'm going to say indicates. I'll use the same verbiage there. A value is equal to the mean. Okay. So there's some rules here for your z-scores when you're comparing them. So this tells you where you are in a distribution. It's the same thing like a percentile, except now we have both directions of our center. A percentile only considers data to the left. This one is telling you where you are from the mean, right? How far away above or below the mean. And this is going to be a very important topic in this class, this idea of z-score. Again, we already said standard deviation, which is in this, and that's what we're measuring here, is very important, okay? Looking into the study guide, 15 is basically the definition. A standard score describes what? You have A, B, C, D, E there, pick the best one. 16 we've answered now. If the values in a data set are in feet, what are the units for the standard scores? Remember, standard scores, they don't have units of measure. We just said that, okay? Then some of these are asking you to do calculations for z-scores on here up until 20, okay? Hold on. Yeah, all the way up until 20. And so really one of the biggest advantages to this, which actually I need to write one more note here. So let's write a star. This is important because if I did let me do a z-score for the 78 here. So let's go back. All I have to do, if I go back to my calculator, if I want to do another one, I just highlight. I'm going to change this to the 78. I'm going to put a decimal in there just so that it gives me a decimal. Look at that. Negative. Oh, I did that wrong. Hold on. We want the 78 to go here. I was like, why is that negative? 78. Okay, 2.46. Okay, so we have a z-score. This is almost 2.5 standard deviations above the mean. That's really far up here. We've talked about this distribution a lot. This is an unusual data point. This one is unusual here. Let's figure out that one. That one is 52. Let's go up here. Let's do 52. Those are what we consider like outliers. They're really far away. So here is our general rule for like outliers or z-scores that we'd say are extreme. Okay, a z-score greater than 2 or less than -2 is considered unusual. Okay, so we're looking for that. So it is very unusual, especially in our distribution. We see the overall pattern. Most people, the average is this green line. It's symmetric, a roughly symmetric distribution. Here's the normal. These people are abnormal. Okay, not that that's wrong in every context for sure, and that's not what the point is. It's just saying they are unusual compared to what is expected. Okay, that's really what this is saying. So that's what z-scores do. Okay. Lastly, let's talk about one of the best uses of this. So z-scores are good for making comparisons of individuals in separate sets of data. Okay, so if we have separate sets of data, let's compare Central to Stewart's Creek High School. Let's compare ACT scores. Well, obviously, if I compared you to a Central student's ACT score, the odds are you're probably worse score, right? But that's not really a fair comparison at all. We would compare your relative position in ACT, right? So how did they do? Were they above average on ACT? Are you above average? How much more above average are they compared to you. You may be better at ACT compared to where you are. Okay, so that's really the purpose of Z-scores, to make this comparison. Now, I've never done this in a stats class, but let's do this classic comparison. Michael Jordan versus LeBron. LeBron James. Who is the GOAT, right? Who's the best of all time? Who is it? Well, how do we make this comparison? They've argued it for years, since he came out of high school, out of Akron, Ohio. You know, he's supposed to be the chosen one, right? I don't really care much about it. I'm not a huge NBA fan myself, but it is always interesting to talk about this. They always bring up statistics. So it's important, especially for those that are enthusiasts with sports, and sports is riddled with data, to understand how to make these comparisons properly. So this is what I did. I Googled Michael Jordan, his best year. I said, okay, how do we compare these players? Well, maybe it's their points per game. Maybe that's how we can do a comparison in maybe their championship year. How did they compare points per game wise? So we went with that. So you may not agree. I know some of y'all are super NBA fans, and you'd say, Mr. Woods, this statistic that's not how we would compare them. We want to know their efficiency. Blah, blah, blah. I don't really care. This is what I went with to make my point, make my lesson, okay? So we have points per game. And so we're talking about Jordan. Points per game in his best year that we found, or that I found online. I Googled it. So, you could also argue with points. Is the 90-91 season. There's a documentary out about the Bulls and Michael Jordan. Actually, it's the Bulls. It's the whole team themselves. So let's talk about Michael Jordan's point per game in 90-91. He had the most points per game for the whole league. So here is look at this data that I found. Holy cow, huh? Huge spreadsheet of data. And over here in this far right column, he had 31.5 points per game. Okay? So what I want to do is I'm going to take this entire data set right here. We're going to take all of it, and we're going to paste it into a new spreadsheet. So I'm going to make a new document here on my Inspire. I'm going to paste this. Now I don't want this, and I'm actually going to delete this row. Now we have that. So we want 90, 91. I'll say 90-91 PPG. I don't like that. PPG. There we go. PPG 90-91. Then we want PPG for LeBron. LeBron's best year, according to Google, was this year. He was third ranked for points per game, but it was 27.1. Now, automatically you're saying, well, Mr. Woods, 27.1 is less than 30 Michael Jordan's points per game. He had 30. Let me go back to that, and I'm going to write that down. You can write that down in your notes. 31.5, obviously. So Michael Jordan's point per game is 30.1. 31.5, whoops. 31.5, so write that down. What about, and so automatically you're looking at this and you're saying LeBron's season, the 13-14 season, points per game for LeBron was 27.2, and you're saying, Mr. Woods, right away LeBron loses. Or no, it's 27.1. Whoops, I'm writing all this wrong. And, oh yeah, he loses. But that's the same thing as saying relative to the mean. That's what we're trying to do here. We're comparing it to the center. Is Michael Jordan way higher than the center? Way higher than the center, the average for that time period? How does LeBron compare? We know he's not number one or even number two. He's number three. But is he still far enough from the average that we could say, okay, he's better? In their best year, he was better. So how we do that is we are going to... so this is... I'm all scattered right now. Hold on. 13-14. So 13-14. And And we're going to copy and paste this next list here. I want points per game here. Control C, put it in here. Oh, I did this wrong. Let me insert row. Okay, so here, and we'll delete this. Okay, so we have these. Let's go ahead and calculate the means. So I want the mean 411. We want 9091. This is Jordan's. Okay, look at that. Oh, by the way, this is the top 100 players. So there's 100 players in here on the left. And for both data sets, it's 100 players. There were more in the data set that I could have got, but the top 100 players, this is their mean. So 17 point, we'll do 19 and 4.46. Okay, so mean and standard deviation, both of them. So we start 17.19 and 4.46 is the standard deviation. So it's mean, standard deviation. Now let's check LeBron's. Go to another column, menu 411, 1314. Ooh, look at that. The average scoring of the top 100 players is less. So that's actually good for LeBron's argument. That actually means that he is higher than the mean, right? And maybe by a more significant amount. Also, look, a smaller standard deviation. Quite a bit smaller. That actually might put LeBron ahead right there. Again, I've never done this, and I haven't taught this in class either, so we are discovering this together. This is 3.97. Okay, let's calculate their Z-scores. So the Z-score for Michael Jordan is 31.5. Take away 17.19. You're dividing that by 4.46. That'll tell us how many deviations there are from the mean. Let's do the next one for LeBron. So this will be Michael. This will be LeBron. 27.1 minus 16.71 over 3.97. All right, let's do the math. Let's see what we get here. I'm going to minimize this. I'll put it over here. Do that. Okay, let's do this. Control there. Oh no. Control divide. We want 31.5 minus 17.19 over 4.46. Okay, that's a pretty unusual, right? That's above 2. So he got 3. We always go to 2 places on our Z-scores. All right, the moment of truth. This is what we need to see if LeBron did it. I kind of think LeBron's is going to be higher based on him being above the mean so much. Oh, man. Okay. So based on this, you know, they're both obviously above the mean. But this Z-score is more telling about how much better Michael was for his time than LeBron is for his time, even in like what we would call their prime, right? Now, you could argue, you could say, what you could do to extend on this is you could say, well, what about how did the Z-scores compared for the entire careers? And you could get a Z-score for their points per game every single season. If Michael was higher every single season, I almost feel like that is gonna be the telling factor. Like, is he better than LeBron? It looks like it. Now, you may want to do this with assists as well, and you could do for every statistic that you think is meaningful. And this could be a very interesting project to do. I'm actually kind of interested in it myself. I want somebody to do it. To figure that out. So if you're interested in getting this data sheet that I found, or a link to the site that I got this on, you can email me and we can talk about it a little bit more. But this is what Z-scores are for, and we're going to close up this video talking about our study guide just a little bit. So this is a 25-minute video. That's what this wants. So number 19 says, Jack and Jill, both enthusiastic players of a certain computer game. Hey, me too. Over the past year, Jack's mean score when playing the game was 12,400, a standard deviation of 1,500. During the same period, Jill's mean score was, and it gives those, okay, in deviation. They devise a fair contest. Each one will play the game once and compare Z-scores. Jack gets 1,400, Jill gets 1,600. Who won the contest and what was their Z-score? So here you're looking, just like the Michael versus LeBron example, you are trying to see who has a higher Z-score relative to their performance on average, okay? So Z-scores are very fun, in my opinion. I like them. They tell you a lot when you're doing comparisons. So hopefully you have a pretty good understanding now. You should be able to do in this study, in these problem sets, 1 through 20. Remember, there's 54 questions. So we're already 40% of the way through this. Next week, we're going to knock out the rest, okay? So I'm going to go ahead and stop the video here, and this will sort of conclude this week.